Thanks. I'm dialing in from Nipaluna, Hobart, which is the traditional lands of the Muanina people, and I pay my respects to their elders, past, present, and the Palawa people who are the continuing custodians of southern Tasmanian lands. Since we saw you on the 23rd of March, it has been apparent that the things we talked about over the summer have continued to push into winter and spring. And so we will continue to see climate variability play a pretty strong influence in our marine waters all around Australia. Since the last update, the fifth worldwide coral bleaching event was declared, and this means that coral bleaching has been observed right around the planet over the 12-month period. And thanks very much again for the feedback around things that you would like to see more and less of in these updates. And as Claire and Jamie have said, we'll conclude this one with a little bit about thinking what do we need to do into the future around these extreme event planning. We have talked a lot about climate drivers in these, particularly in the opening parts of each one of these seminars. And we wanted to just say, why is it that we focus on climate drivers? Because we have a model and the model is producing the forecast. So why don't we just trust the model and just talk about that each time? Yes, the model is producing a forecast, but still, just like the weather forecaster who gives you your television forecast, we want to look at what's happening around the region and make sure the model is consistent with our expectations. The models have some level of skill, and by us adding additional interpretation, particularly around the behaviour of climate drivers, we think we can develop more confidence in what the model is telling us. And so this model that we generate forecasts with is still influenced by climate at a range of scales, and that makes operating without a model difficult. It makes operating with a model a little bit easier. And so it's particularly complicated forecasting these days because of carbon dioxide levels in the atmosphere. They change the global temperature. Climate drivers then affect where those temperatures are expressed. And then local conditions operate on top of all of those. And each one of those is operating at a different time scale, with carbon dioxide giving us centennial or 100-year kind of drivers. Climate is somewhere between 6 months and 2 or 3 years, and then local conditions are quite difficult to forecast, and so they operate on shorter timescales than the model predictions we're giving you. This year in particular, we focused a little bit on the El Nino Southern Oscillation and the Indian Ocean Dipole, but the schematic on the right shows that the climate driver influence on Australia is more complicated. For example, while we've done the left and right-hand sides of Australia with El Nino, La Nina, and positive and negative IOD, in the Southern Ocean, we've got the Southern Annular Mode, which dictates how far north or south the westerly wind belt is found. In tropical regions, there's a driver called the Madden-Julian Oscillation, which influences how cloud bands and temperature patterns move across the Australian continent. All of those things then interact on our strong boundary currents, the Leeuwin Current in the west and the East Australia Current in the east. Next summer, I think we'll try and build the sophistication around interpreting some of these other events because they can help you understand what will happen between the forecast when we issue it and the actual events that emerge. This schematic on the left just shows a quick example of what I mean by the complexity from the different driver scales. So carbon dioxide levels give us global warming. And so in the schematic immediately below that, you can see that temperature time series has generally increased from the 1880s to the 2020s. That's the climate change signal. On top of that, you can see in this case, the ENSO signal, which has got red years that were classified as El Nino and blue years as La Nina. So in any kind of 2 or 4 year period there, you can see the red dots are generally higher than the blue dots. And so that's the signal of ENSO giving us this slightly higher or lower temperatures. And then the third scale, which is the regional weather, such as a high pressure system. So if a high pressure system sits over an area of the ocean, it's generally got less clouds, a lot more solar radiation gets through, and that can lead to more rapid heating of surface waters. That's indicated by the little red bar at the end of the time series, which says even in an El Nino year, we will have regional weather then giving us an impact on what we see. And as an example of how these drivers play differently in Australia, this is just a schematic that shows for the 4 seasons of Australia's ocean climate, what, if you had to pick just one, is the dominant climate driver of that region? And you can see the different colours saying that in some areas it's a blue climate driver corresponding to La Nina. In other cases, it's related to something called the subtropical ridge high or the Indian Ocean dipole. Now, whether that drive is very significant or not, you can't tell from this figure. But if you just had to pick one to pay attention to in your region, this might be it. And we'll try and explain that more in the series next year. So looking back over the summer then, we did focus a bit on El Nino because when it was declared in mid to late 2023, it was going to be coupled with this positive Indian Ocean dipole signal. And that was going to give us a double impact of warming around the Australian continent. And so particularly we got together because of this concern that we would see impacts that might be like what we saw in the last big event of 2015 and 16. This is the sixth, you already know that because we welcomed it to you. And again, the goal of this is to build awareness and capacity for 4 sectors that are interested in the ocean: industry, research, management, and policy.
All right. Thanks, Alistair. So I will run through the current conditions we've got around the Australian coastline at the moment, and then step through the forecast for May, June, and July. So hopefully this is all moving on your screen. So this is just a little movie. It'll just loop. All it is stepping through the ocean conditions over the summer. So anywhere that is pink is warmer than normal. Anywhere that is blue, and there's not much of that, is cooler than normal. So it starts in November. The dates are up the top. These are weekly snapshots. And I just thought it was interesting to see how the summer has evolved. So it runs through, this little video runs through the end of April and then just loops again. So if we time it, and now for November, this is the El Nino signal out here in the Pacific. This is what it typically looks like. You have a big patch of warm water in the surface and at depth stretching across the Pacific. And you can see around Australia, we talked a lot around what was happening in the Western Tasman Sea and around Tasmania. You can see how that heat is changing over the weeks as we step through. We're now in January, and how that heat has developed on the east coast. There's also been that cooling on the west coast, on the northwest shelf. You can see it's white, which is normal conditions, blue where it's a bit cooler. But it just gives I think it gives a really nice idea of how dynamic the ocean is, how things are changing, but how you can see that what's happening out here, what feels like a long way away from here, is actually affecting what's happening in our regional areas. So I think that's just gives a really nice overview of the summer. We step through, so I don't have April, the April values yet because it's only, the 3rd of May, sorry. So what I've got here is March because we didn't get a chance to look at them last time. So on the left, it's showing sea surface temperature, so that very top layer of the ocean. Anywhere that's dark orange, this really dark sort of pumpkin color, highest on record since 1900. So you can see that area, and we talked a lot about it in the last briefing. At the southern end of the Great Barrier Reef and northern New South Wales was the highest on record in March. What seems benign, this sort of apricot colour, is still in the top 10% that's been seen in these locations in the last 120 or so years. So all down the east coast, around Tassie and across the Bight has all been in that top 10%. So it has been really warm on the east and southern coast in March. Whereas the west coast, this sort of grey colour is around average. So it's been either cooler or around average. So I guess March is, officially autumn, but just recapping on the summer months, so December, January and February, they were the warmest on record for all of Australia. So sea surface temperatures this year since 1900. So it has been a very warm summer, and a lot of it has come from these large areas that have been particularly warm. We put it in context. This is the average basically of this box here that you can see. And this is where March fits. So we're the 3rd warmest for March using this data since 1900. So you haven't imagined it. It has definitely been warm this summer. So looking at the recent, so this is last week, 22nd to the 28th of April. And just up here in the corner is what we were looking at during the last briefing. It's pretty similar. I'll get into what the El Nino event is doing or not doing in the next slide. We can see the same patches lighting up. So Western Tasman, off New South Wales coast, there's a bit of warmth down here, sort of Southern Ocean and off the coast of WA. Northern Australia and through the Bight, at least inshore at the moment, are around what you'd normally expect for this time of year. If we look at the marine heatwave tracker, so this is from the 30th of April. This is a snapshot at the surface. And for those new to the briefings or that need a reminder, a marine heatwave is the top 10% of that location of your temperatures for that time of year. So it's all relative to your location. So you can see the Great Barrier Reef and parts of the Gulf are in marine heatwave conditions. And that's no surprise given the bleaching that's been going on there in the last month or two. That same area off northern New South Wales is still in marine heatwave conditions, and parts of the western Tasman Sea down here as well are in marine heatwave conditions currently. If we get into the water, so this is the top 300 metres. So it's basically taking the average of that 300 metres, and anywhere that's yellow to red is warmer than what you would normally expect. Anywhere that's blue is cooler. So these patterns haven't changed a great deal since last time we spoke. So you can see these really warm areas off New South Wales. These sort of round spots usually correlate to an eddy that's been sitting there that's either warm or cool. New South Wales, that's no surprise for anyone operating there. It's very eddy rich. We've also got a lot of heat at depth around in the Tasman as well. Pretty cool off the coast of WA. So as a reminder, we look at what's happening at depth, so that if you've got a warm surface layer and it's just a very thin layer, you get a few windy days, a good strong sea breeze, that's going to mix that warmth down. But if you've got warmth already sitting deeper into the water column, it's much harder to move that warmth on. So that's why we're looking at the subsurface as well. How did the forecast that we showed in the last briefing pan out? So we've got the first 2 fortnights here. So that was the end of March or second half of March and the first half of April. And then the forecast for April as a whole. Across the top were the forecasts I showed you last time. Down the bottom is what was observed using satellite measurements. So the model's done a pretty good job. So for the first 2 fortnights that we had in March, we've got the patterns were cooler down the west coast and into the Bight for both those fortnights, which is what was predicted. Warm further offshore and warm in the Coral Sea and the GBR. For April as a whole, it was a bit warmer in the GBR than the model first indicated. The model said that temperatures would be at least a degree warmer than normal. That was a bit of an underestimate. So observed temperatures got up around 1.5, possibly 2, but still indicated it was going to be warmer than what you would expect. It was also much cooler on the northwest shelf for April as a whole than the model first predicted. But in general, the patterns are relatively consistent, which is good. Gives us confidence in the forecast when we're looking at it. What about our marine heatwave forecast? So that's based on those sea surface temperatures. So this was what was observed. So it's not, we're missing a couple of days of April because we haven't got the data. Gives you the idea. That matches up to this box. So this plot here on the right was the forecast we looked at, the last briefing. This box here is basically this region here. So the model has picked up marine heatwave conditions off New South Wales and that it was a strong marine heatwave. We had a few bits and pieces down here in the southern and further offshore in WA, and also has picked up that there were marine heatwave conditions in the Great Barrier Reef. Didn't quite get the extent or the amplitude of it, but has definitely indicated that was an area of concern in March and April. Sorry, in April we're talking about. Okay, so looking forward now for the next 3 months. And so I want to preface this here as obviously we're going into winter. So your summer marine heat wave, your actual temperature in the water is obviously going to be a lot higher because we're looking at the top summer temperatures compared to what you might get in winter. So the important thing to think about is that if you have a warm winter, what are your processes that are happening there? What decisions do you need to make and what impact does a warm winter have? And Alistair will go through some more steps in that later in our presentation. So we're taking a bit of a global outlook. So this is our Nino 3 region. This is our box in the Pacific. It's one of our indicators that we look at the Bureau, whether it's an El Nino, a La Nina, or it's neutral, which is neither. So you can see that that big red tongue, we would say, that we saw in that video is pretty much disappeared. And basically the El Nino event of 23-24 has finished. And I'll show you that in the next slide. Around Australia, we're seeing same patterns. So this is for the next 3 months on average. We've got that heat's just going to hang around off New South Wales and also in the Western Tasman. But we're starting to see some more heat off southwest WA and extending out into the Southern Ocean. So if we look at what the ENSO, so the El Nino or La Nina conditions are, the event has finished. So all the indicators that the Bureau looks at, they have returned to what we would call normal. So it's inactive, it's neither one or the other. And the models are indicating it's likely to stay like that through till at least July. So it is not the only indicator we look at, but as Alistair showed, it is a really big driver of what's happening in the ocean around Australia. So this is the Bureau's model here. In this pink region, this is when conditions were in El Nino, and you can see it's declined as we've passed through summer and into autumn. These grey lines are all the model runs that we do. So we run a whole suite of forecasts and we look at where those forecasts are pointing. A majority in the neutral area are more in the El Nino zone or La Nina. You can see there's a few lines here starting to drift into La Nina conditions by September, October. But typically all the models, Bureaus included, doesn't have a lot of skill at this time of year for predicting what's happening with ENSO later in the year. So typically we would say watch and wait. We get through to around June, we'll have a much better idea of what ENSO conditions are likely to look like. If we're checking in with the other areas, other institutions around the world, the Bureau's model is at the top there. Same colour scheme, pink El Nino, white neutral, blue La Nina. So the top one is for May. So we're all sort of sitting in this sort of neutral zone. As we step through to July, so skip a couple of months ahead, a couple of models are suggesting we might be heading into a La Nina. And as we step into September, another one, so 3 out of the 7 or 8 that we look at is suggesting La Nina. However, they have the same issues with trying to predict that this far out as the Bureau's model. So it's a watch and wait. And that'll be something that we'll look at when we're planning the series of briefings for next summer. So we look at rainfall and temperature. So for folks operating inshore or in estuarine conditions, important to know that. So the rainfall outlook for May through to July, again, drier than normal, at least in the north. So across northern Australia, it's looking quite dry. This is your chance of exceeding median. So what your sort of median rainfall for that season. Northern Australia is pretty low chance that you're going to get above median. Parts of Victoria, parts of Queensland, and parts of the Bight as well. That's just above median. So you could be slightly above median and it's not going to be very different from your season. If we want to look at the extremes, so we want to know, okay, where's it going to be really dry or very low rainfall, so that the lowest 20%, that Northern Australia area is still lighting up, parts of Victoria and also parts of Tassie, which I didn't mention earlier. So if you're operating in an estuarine system or very inshore, just keep that on your radar, that it's unlikely to be particularly wet, sort of late autumn, early winter. However, I feel like a bit like a broken record with this slide because it pretty much looks the same every time I present it. This is for your maximum temperature, so your daytime temperatures. Okay, so everywhere is red on the left. So that is showing it is going to be warmer than normal May through to July. Same pattern, above median. On the right, is it going to be in the top 20%? So is it going to be particularly warm during the day? Southwest WA is lighting up, parts of Queensland, coastal Northern Australia, and Victoria and Tassie. So it doesn't completely line up with the dry areas, but in some areas they will overlap. You're going to get pretty dry and pretty warm relative for this time of year. Okay, getting in the water now. So these are the next 2 fortnights. So this is for the first half of May on the left, second half of May on the right. Same deal again. Anywhere that's red to purple is around 1 degree or more warmer than what you'd expect for this fortnight. Anywhere that's blue, cooler than usual. So it's a pretty consistent pattern from what we saw in the April observations that we looked at a few slides back. Cool on the northwest shelf through the Gulf as well, and extending offshore out past Ashmore and Rowley Shoals, those reefs out there, and also cool in the Bight, so inshore on the shelf. However, there is still persistent heat in the Great Barrier Reef, but not the same kind of anomalies that we were seeing before. So it has backed off a bit, but it is still warm in parts of the Coral Sea. This feature here that we're seeing off northern New South Wales looks like it's going to hang around. So it is still very warm in parts here for the next 2 fortnights. So we're up around possibly 2 degrees warmer than you'd normally expect for this time of year. That heat also in the Western Tasman is there. The model is predicting that to persist. And if you remember back to the few slides back where we were looking at the subsurface, that's where that heat was sitting. And so that is what is influencing what's happening at the surface. The new sort of area to look at that we hasn't featured so much in the previous briefings is this Southern Ocean and sort of southwest WA. This is really starting to warm up here offshore, extending, sort of southwest. So it'll be interesting to see how that pans out and what that means for WA folks who are operating in warmer winter waters than you might normally experience. Bearing in mind, we've got to look at the model skills. So how well has it done over the last 40 years predicting this time of year? And for these next 2 fortnights, the model does a pretty good job. Anywhere green, we've got good confidence in it. If we look further out now, so we're looking June, July, it's the same kind of patterns showing up again. So that northern New South Wales, western Tasman, and southwest WA and extending perhaps into the Bight are pretty warm. So these sort of purpley colours were up around 2.5 degrees warmer off the capes of WA and into the Bight and further south. So if you're operating down at Heard Island, starting to get warm up in that direction. Still warm across northern Australia, but not as warm as it has been. So about maybe half degree warmer than what you might expect, but definitely the same 3 locations of persistent heat for the next 3 months. Looking at the skill again, because we're looking further out, we're looking, sort of 3 months down the track now, the skill does drop off. These white patches are due to it's very hard for the model to get the eddies in the right spot. But across Northern Australia, we've got good skill and through the Bight and around Tassie. So we've got reasonable confidence in what the model is telling us for the next 3 months. These are a bit patchy down here in southwest WA, but as we saw, that heat is already been observed in the subsurface. So we can understand where it's coming from. It's not just coming out of left field, so to speak, in the forecasts. So there's a reason we're seeing it. Okay, so we're in discussions that we've had since the last briefing. There has been more talk around sort of what's happening in the subsurface. So for interest, I thought I'd pop this in. These are just trial forecasts, so they're not publicly available. All the same model. So those sea surface temperature forecasts we're looking at, it is the same model. So this is where these subsurface forecasts are coming from. Again, 300 meters. So you're not going to see anything in on the shelf. It's pretty much white, but you can see the same sort of pattern and what is being reflected in the surface. So we've got offshore of New South Wales, Western Tasman, and this area down here in the southwest, there is a lot of heat at depth, and that is what is being reflected at the surface. So it also gives that persistence of that surface heat, because we've got so much in the subsurface, it's just kind of hang around. It's going to take a while to move it on. So I just thought for interest, you can see these sort of coloured, sort of almost like little circles here on the New South Wales coast. They're eddies, quite deep ones, but the patterns in the subsurface are reflecting what we're seeing at the surface. All right, last couple. So stepping into marine heat waves. So now we're just looking at that top 10%. So bearing in mind, if you're actually measuring the temperature in the water, it's not going to be the same as a summer marine heat wave, but it is warm for whatever is happening, during those times of year. These plots here are showing you what's the chance. So if you're in the sort of green to dark green, you've got a 70 to 100% chance, based on what the model is telling us, of a marine heat wave. So we take all our forecasts and we look at them and say, well, how many of these are telling us marine heat waves? So this dark green area, 80 to 100% of the forecasts are saying marine heat wave conditions. Again, same areas. So northern New South Wales, Western Tasman, and then this area down here in southwest WA. And that is the pattern for the next 3 months. We're seeing that here for June and for July. There's a low chance of marine heat wave conditions in the Great Barrier Reef. Not no chance, but not as pronounced as what we're seeing in the southern end of the reef and northern part of New South Wales. If we then take all those forecasts that have given us those odds and we collapse them down just to see, what's the average marine heat wave conditions, same spots light up, northern New South Wales, Western Tasman, and there is quite a persistent marine heat waves and up to sort of strong, maybe severe conditions further offshore from southwest WA, and that is predicted at this point to hang around for the next 3 months. So part of our discussions as we move through winter and spring will be, what does that heat mean for next summer? And I think that is it from me. So I'll throw over to Alistair to wrap it up for us.
So we've gone through the hottest part of the year where the absolute temperature is the greatest, but we're still going to have this warm winter. And so what does that mean in terms of the biology of the animals that are living in these areas? Generally, it means that they've, have been stressed for 2 or 3 seasons in a row now. And particularly in southern Australia, animals are adapted to a cool period in winter. And that's often when some species do their gonad maturation and are putting on condition for good spawning seasons. So if you're working with species that typically build gonad mass and put on condition in winter, I think it'll be a very stressful period of time. That means that you might see recruitment being impacted next summer just as a result of the warmer winter. So thinking again about, well, what do we do in response to a forecast like this? We have much less experience in thinking about what we do when spawning is being affected or when gonad maturation is affected. We're not really sure about what that means in terms of other management options or how you might overcome that with market solutions. So this is a place where, you're a bit on your own as industry in both the wild and the aquaculture sector in knowing what you can do during a warm winter. If your species aren't particularly stressed at that time of year, though, it is a chance for recovery, looking back at how you were affected this year and thinking about how you're going to prepare for these extremes as they come again in future summers. We've already had early warning, though, for the Western Australia and the southwest area that I'd be starting to think about my preparation plans for the next summer now. Just remind you of this agility wheel on the right-hand side. If you found yourself constrained by a regulatory environment that limited the options that you wanted to exercise, perhaps now's the time to think about what the regulation environment might need to be for the next summer. How do you respond to different market forces and so on? So keep thinking about these 7 areas that give you some directions to look for adaptation agility. We've mentioned at the last briefing, but both New South Wales and Tasmania have developed marine heatwave response plans, and these documents will definitely give them a leading advantage coming into the next summer. In those documents, they've set out their early warning system, how they're going to prioritise things through risk assessment, what emergency management response levers they may have available, and what management will do. And even in the absence of a lot of levers, how they will communicate with their stakeholders about marine heat waves in the area. And again, Tasmania, for example, has led with some development of some inshore forecasting approaches that have provided extra information for the coastal regions that our forecasts do not represent as well. I guess I'd say the research community that brings you this effort will continue to keep in touch over the winter and make sure that we're preparing for the best dissemination of information next year. So, this is the end for us in terms of this emergency response set of briefings, but we're definitely thinking about how we're going to make sure that the information we're delivering can be most used and make the best of what can sometimes be challenging environmental conditions. So if you just click one more time, Claire, you'll bring up the last 2 points I wanted to make. So as Jamie said, we're planning for a series of briefings over the coming summer and perhaps starting in about September, unless we get really early warning that things are going to be ugly earlier than that. We'll continue to work on operationalising, which means making available to you more easily the surface marine heatwave forecasts, and we'll continue to test the temperature depth forecast that Claire gave you a sneak peek at a few slides earlier. I do think as a community, though, we need to think hard about how we're going to build capacity and resilience more generally for Australia. And on the next slide, for example, is it through a national research project? And I think about a national research project in the context of what else do decision makers need to know to prepare for next summer? Do we need to have more rapid sampling responses so that we have a good sense of when warmer temperatures are coming or already in an area, what taxa are being most impacted? Do we need better indicators of ecological stress? And the best indicators are all leading indicators. A fish kill is a pretty poor indicator because it's already happened, but an indicator of stress in fish, for example, in body condition or in physiological measures, might be a really nice example. And the graph that I'm showing in the lower left is what happens to bacterial communities in ocean waters during periods of marine stress. And the bacterial community is the base of the food web. So maybe you can see responses there that might be able to be used to say, yes, in this area, the temperature stress has really now moved into the food web and we expect it to propagate up the food web. So along with questions that Jamie will ask you, can you think about in the chat or coming back to Claire or I afterwards, as industry managers, policy or researchers, what else do you need besides the information we're providing to help you in your decision-making process? And with FRDC, we're trying to discuss with the community a proposed national research project that would detect ecosystem impacts and will give us a bit more insight into what's going on. And the best place probably is at low trophic levels. Think about the prey that a lot of other things depend on, or the chlorophyll levels that feed the bivalves and other filter feeders in aquaculture. So could we leverage IMOS infrastructure around Australia with some additional sampling? If you're able to do that, it'll give you not only these early indicators, but it will take our research community to providing not just heatwave forecasts, but ecosystem forecasts. For example, a prey availability map or a physiological stress map that would show you where species or taxa groups around Australia are stressed as a response of heat waves. So please help us by thinking, what do I need to know to do my job better next summer? Thanks, Claire. We'll wrap up with just reminding you that over the intervening months, we've got the FRDC Extension Officer Network, which is available for information and can gather your queries and bring them back to you, bring them back to us or other experts in this area. So please continue to use that as an on-grounds listening and information resource. And with that, Claire, we just, on behalf of Claire and I and Jamie at FRDC, I just say thanks very much for trying to learn and be as best prepared as you can over the summer. And I hope you do feel that as a community, we have been better prepared than ever before. Thanks.
Thanks, everyone.